So this paper really should be sitting with you as you type up your lab report. Results, you'll put your results in a data table. A discussion and conclusion, right? The analysis and conclusions were referring to questions that are on the actual lab sheet itself. The overall spelling, grammar, every time I find a spelling or grammar mistake, you'll lose a point. Multiple paragraphs. Some of you had a really, really long theory or a really, really long discussion and conclusion. Remember, part of good writing is that you're breaking things into paragraphs based on things that go together. No contractions. You didn't lose any points on the first lab report for contractions, but I probably highlighted them and said, don't use contractions in formal writing. So when you're doing formal writing, you should type out the word cannot instead of can. If you use some, I probably picked up on them and I probably highlighted them for them, but you didn't use points. On this lab report, every time you use a contraction, you're going to lose a point. Probably the easiest way to fix that is honestly, don't worry about it as you type up your lab report, but when you're finished, before you submit it, go back through and read it, and if you use the contraction, just change it then. That's probably the easiest way to fix that. And then last name and page numbers, most of you did that correctly, but there were some of you who it wasn't in a header like it was supposed to be, and it wasn't insert a page number. Again, if you don't know how to do that, just ask me. It's really easy. And once you see how easy it is, you'll be upset that you tried to do it any other way. Okay? So if you didn't get full points on the last rubric for formatting, likelihood is something was not quite right with your last name and page numbers. Okay? So this paper realistically should be sitting at the computer with your Chromebook, whatever it is you're typing on, as you type up your lab report. So going over the lab itself today, again, this is what we'll always do the day before we do a lab to make sure that everybody knows the procedure. Occasionally, I'll ask you to kind of change things, okay? And so you need to kind of make sure that you have.
When elements such as carbon are heated to high temperatures, some of their electrons are excited to higher energy levels. When these excited electrons fall back to lower energy levels, they release excess energy in packages of light called photons, or light quanta. The color of the emitted light depends on its energy. Blue light is more energetic than red light, for example. When pattern of light energy, which is useful for identifying the elements. The characteristic colors of light produced when substances are heated in the flame of a gas burner are the basis of flame tests for several elements.
Also, so again, this is kind of explaining what we're doing. So the other day in our notes, we looked at those emission spectrum and how there were specific lines. We talked about the fact that different elements give off different characteristic colors. That's what you're going to be doing. You're going to be burning these in lab and seeing what colors you observe. Okay? Materials-wise, you will have to wear goggles. Okay? Everyone will have to wear goggles on Monday. The platinum wire or nichrome wire, you'll be able to tell that's like on a little handle and that's got a little wire on the end. The beakers are there. You won't need test tubes or test tube racks or scupulas because I'm already going to have all the chemicals are already in little test tubes for you. Okay? The cobalt blue glass, that's a blue colored glass. The gas burner is the Bunsen burner. You won't need paper towels. Okay? I will have, there's hydrochloric acid. Once everybody's kind of at their lab stations, I will walk around and give you a little bit of hydrochloric acid. Potassium nitrate, calcium nitrate, strontium nitrate, lithium nitrate, copper 2 nitrate, sodium nitrate, barium nitrate. Those will be in the test tubes, and the test tubes are labeled. So you'll be able to tell which one is which. The unknown salt, so that you know when you get to that, it's one of these. Your unknown is one of these. And that's part of what you'll see with the procedure that you have to figure out is what is your unknown, which one of it was. So the little safety first paragraph there, please, reading.
In this lab, can harmful materials. Once in contact with these chemicals, observe all precautions, especially the ones listed. The safety icon is the final step in the procedure with their
All right, that first one there, Margot. You guys, they need to cover your eyes, not your forehead, not your chin. And I recognize that with our masks on, they're more likely to fog up. They do have vents on them, okay, that we can kind of play with and try to make it so they're not fogging up. Right. The next one, please, Scott. One, yes. So again, hopefully we all know that we don't taste things. Okay. The next one, Madison. Duh, right? We're putting it in a Bunsen burner, but you know, there are those people out there. And the next one, please. Okay. So again, when we get to that step, I'll tell you, but again, all you're going to do is you're going to end up putting the tops back on nice and tight so that I can use them again the next time. Okay. All right. The procedure, the sentence before the procedure there, Sean. So let's take a look really quickly at data table 1. One of the things you see here, right, this is a pretty simple lab in that you're just observing flame colors. You're going to be working in groups of 3, okay? You do not all have to have the same observation. Everyone's eyes perceive color differently. You should write down what you see. In addition, sometimes girls will use the color magenta, but sometimes boys have no idea what color that is, or even other girls. Don't use the word magenta if you don't know what color that is. Okay? So you don't all have to have the same description of the color. Everyone's making their own observations. This will also be true for the people who are watching the video at home. When they're watching that video, they're going to just watch the video to like see what colors they observe, okay, as you do the lab. Whoever is the guinea pig group that gets kind of recorded during the lab, okay? So that is there. Now, sodium, right, it says Na+, that's going to be the sodium nitrate. The chemicals on the front page, they had their full names. Here, they're just saying what ion it is. All right, back to the procedure then. Step number 1, Beatrice, please. I already will have done this step for you. Okay, your test tubes are already going to have samples in them, and they're already labeled, so you will not have to do step number 1. All right, you might want to jot that down so you remember that. Okay, number 2, Erin. 6 molar. You read it as 6 molar. So what they're kind of showing you that, right, in that figure at the bottom of the page of 20.1a, one of the things about this, So we don't get the really good, expensive wire that doesn't have a color to it. So I want you to clean your wire and make sure it looks like it's clean. But likelihood is your wire is still going to kind of glow a color. Usually it's kind of an orangey color. If you have dipped it and cleaned it and you've looked at your wire and it looks really pretty clean to you, your wire is probably going to have a little bit of color to it. You probably should jot down what color it kind of has so that you can kind of take that into consideration when you're doing your flame test, right? Because you're going to have to decide, is that the color of the stuff I'm burning or is that the color of the wire? But it shouldn't, your wire shouldn't give off a big, huge flame. It should be kind of like the wire itself kind of glows a color. If your wire kind of itself glows a color, it's not probably dirty anymore. Okay? The next step, please, Riley. So one of the things that sometimes happens here, okay, for step 3, is sometimes people have a hard time getting the sample that's in the test tube to stick to the wire. One of the tricks that you can use for that is you can use a little bit of water or you can even use the hydrochloric acid that you've been using and kind of moisten your wire. And then put it in the sample, and likelihood is the sample will stick to your wire because it's wet a little bit better. A couple of them are kind of bigger and chunkier, so you may have to kind of do a little maneuvering to try to get one of the chunks to sit on your wire. Okay? If you're really having a hard time getting the sample on your wire, let me know and I'll help you get some on it. Okay? But you may have to be a little bit creative with it. Like I said, sometimes if they're really powdery, if you get your wire wet, it'll stick to it. Okay? And sometimes if they're kind of big and chunky, you kind of need to do a little maneuvering to try to get like a piece on the end of your wire and to stay there. Okay? So again, a little bit of work sometimes to get your samples on. Make sure everybody's ready to make their observations in case it's gone pretty quick when you put it in the fire. In case it was real hard to get it on there, you don't want to have to try to get some more sample up there to do the observation. Okay? And again, you're going to clean your wire in between each sample. Okay, so you get a sample on it, you burn it, everybody writes down their own observations of the color that they see, you burn it, make sure it looks like it's pretty clean, you dip it in your hydrochloric acid, you clean it a couple times, and then you do the next sample. It doesn't matter what order, honestly, you do them in. And notice, sodium and potassium, you're supposed to also observe them looking through the cobalt blue glass. You might do that when you do sodium the first time. Like if there still seems to be sodium on your wire, instead of like cleaning it off and doing it again later, you could do it and look at the sodium through the blue glass right away and not have to clean your wire again. Okay? All right, number 4, I think we're out of it. So idea is if you're looking through it through the cobalt blue glass, is your observation supposed to be the same or do you think it's going to maybe change? What would you guess if they're asking you to do it? Probably going to change, right? So again, kind of do that critically and kind of look for what changed or maybe what's different now. All right, the next one, please, Bryn. All right, so one of the things to add in your data table right now is next to unknown, put a lot, write the word letter, and then put a blank. All of your unknowns are going to be known by a letter. And you are not done and ready to clean up and move to step 6 until You as a group have observed the color and decided which one of these metals here do you have. You have to identify your unknown as sodium, potassium, calcium, barium, strontium, lithium, or copper. And you're not going to turn off your Bunsen burner and be done until you've called me over and as a group said, hey, we have letter A and we think letter A is copper. And I say, yep, you're right, good job. Then you're done. If I say, no, try again, then you have to either like redo it again or talk about your result and decide what else you think it is. So you're not done with the lab until I tell you that you have correctly identified your unknown substance. Does that make sense to everyone? Some of the test tube racks have 2 unknowns in them. If you get the first one really easily and you want to do a second unknown, go for it. There's at least 1 unknown in each test tube rack. Okay? And number 6, I think we're back to Sydney.
Dispose of the unused portions of your samples if they're required.
For me, there is no disposal. You're going to put the tops back on really tight so that I can use them the next time I have Chem 1A next trimester. Okay? All right. We already looked at the data table. Let's look at these analysis and conclusions questions. Again, on your rubric where it said analysis and conclusions question 1, it's referring to these questions. Remember, I am never going to see this paper again. The only thing I'm going to get is your typed up lab report with this information in it based on, and where it goes in your lab report is based on your rubric. So question number 1 is about
list the elements that produce the most easily identified color.
Is everyone's answer for that going to necessarily be exactly the same? No. So more than just list, kind of add here, you also need to explain why. Like, why do you feel those colors, those elements were the most easily identified? Okay? What made them, in your opinion, so easy to identify? All right, Caitlin, number 2.
Which elements are
Right, so which ones did you find the hardest to tell and why? Number 3, please, Scott.
Which element produces the most intense?
Again, is everyone going to necessarily answer that exactly the same way? No. So again, I want a why. Like, why did you feel that one was the most intense? What about it made it the most intense in your opinion? Okay. Number 4.
what kind test is used for detecting metal ions to examine the enrichment of metal ions?
So what they're asking here is, right, when you're doing this, each sample just has 1 element. Even your unknown is just one of the ones that you've done. What they're saying here is, what if you had a sample and it had 4 or 5 of those different elements in it all together? And you were trying to figure out what those elements were with flame tests. Would a flame test work for that? That's what this question is kind of saying. So it's not like your lab where you just have 1. Okay, it's like you have 3 or 4 different ones in one sample. Would you want to use a flame test to figure out what metals were in there or not, and why? Okay. The next question, please, Rainey.
The energy of colored light in order red, yellow, green, blue, white. List the metallic elements used in the flame test and increase the order of the energy of the light emitted.
Right? So the reason they're giving off those colors of light is because those electrons have gotten excited, they jumped up to a higher energy level, they're falling back down and releasing that energy as light. That amount of energy is related to the color. So they've just told you how to put them in order. So you're going to list, this one is, because it was red, has the least energy. This one, because it was violet, has the most energy. So you're going to list that there. Question number 6, Alyssa. So again, right, we said that probably something different should be observed there. What did you observe differently and why did you use that cobalt blue glass? Okay, the plan for tomorrow, we will still come for attendance here. We're going to leave backpacks and things here because we don't take flammable items to a lab. Okay, we're going to leave food and drink here because you can't have food or drink in the lab. Okay, so we will come here for attendance. You can kind of figure out tomorrow or you can decide today, but you'll be groups of 3. It's going to be really, really important because you're working close together, that you're really strict about making sure your mask stays up, covering your nose and your mouth, right? And you're going to be touching the same thing, so you're not going to touch your face, your mouth, those kinds of things during the lab. Always, when we're done with the lab, we wash our hands with soap and water, even when it's not COVID, when we're done. Okay, so everybody, when you're done, will wash hands with soap and water before we come back to this classroom. Okay, so we will work in groups of 3. Remember, you're still all doing your own lab report. You don't all have to write down the same colors. You can discuss as a group like the color. And when you get to the unknown, you need to have a conversation as a group of 3 about what is your unknown and why, and kind of make an agreement. And then call me over to see whether or not you correctly concluded what your unknown was. Does that make sense to everyone? So this is what we're doing. Now I will tell you we're going to have 5 Bunsen burners going in the room tomorrow. Thankfully, it's not super warm this week, but it will be a little bit warmer in there. You may want to be dressed in layers because it's like having 5 little fireplaces going. Okay, so you may want to be dressed in layers so that if you kind of start to get warm, you could take like your sweatshirt off for a little while you're doing your lab. The other thing, so that you don't freak out, is I will probably turn off one of the set of lights in the lab room because it's sometimes easier to see these colors when it's more dark in the room than when it's really bright. I won't shut off all the lights, but I'll probably shut off one bank of lights to kind of make it a little bit darker in the room. Okay. Any questions about the lab?